Have you ever wondered how your clothes, your food, or even your morning coffee actually get to you? Many of the products we take for granted in our daily lives have travelled thousands of kilometres between several countries on their route from raw material to finished product.
Welcome to Sustainable Energy and Mobility of Goods.
The trade of goods is a key driver in economic development, and with the growth of online shopping, consumers have become used to receiving products from anywhere on demand.
The transportation networks that facilitate the movement of this massive undertaking generally burn billions of gallons of diesel fuel moving goods all around the world. And if we're to meet environmental goals set by COP21, this has to change. Ashley, where are we shipping the Sustainable Energy team this time?
Coming up on today's episode, we go trucking and try out an app that may be disrupting this huge business. Marine freight, the mostly unseen and unsung hero of delivery, could be getting smarter and more efficient. And drone delivery, we check out what many believe will radicalise the future of home delivery.
And as always, we've been talking to an expert in today's topic. I met with Professor Anne Goodchild, a specialist in sustainable freight transportation systems, who's been giving us some great insights when it comes to logistics.
If there's one thing that's really revolutionised freight over the last 100 years, it's the humble shipping container, designed in 1956 by Malcolm P. McLean. It's thought there are around 17 million of these shipping containers worldwide, and at any given time, 6 million of them are on trucks, ships and trains.
But what is the cost of moving all these containers and other goods?
Freight accounts for around 30% of all transported related CO2 emissions from fuel combustion and more than 7% of total global emissions. Road transport is the main CO2 emitter in international trade-related transport, producing over half of all emissions. Rail freight produces 76% less carbon dioxide emissions than the equivalent road journey, and a gallon of diesel will carry a ton of freight 390 kilometres by rail, as opposed to 140 kilometres by road. Air freight is often viewed as a poor environmental freight option, but new aircraft are 70% more fuel efficient than 40 years ago and 20% better than 10 years ago.
Roads are the backbone of goods transportation worldwide, and while oil consumption has been falling in many areas of mobility, road freight is not one of them. In London, we discovered a phone app that might make road freight a little more efficient.
There is a lot of research and technology going into energy efficiency in the road haulage sector, from using biofuels and electricity to autonomous trucks. But because of the weight and size of a lot of goods, hydrocarbons are likely to be the key fuel source for quite some time. One area that can make a difference, though, in the short term, is how you manage distribution.
In Europe, there's 100 billion vehicle kilometres driven by freight vehicles. 1 in 4 of these are totally empty. 54% of them are driven less than full. So that means that about half the time, the vehicle is not fully utilised and is not earning. It's extremely important for the overall economic health of the continent that road freight becomes more efficient and we solve these problems of utilisation and resource allocation.
David works for a company that's trying to shake up the delivery industry, an area of business that is historically quite archaic in its processes.
The traditional way of booking a delivery is to manually pair carriers with shippers. So many hours are wasted in that process, in manually booking those shipments. Few matches are short and efficient, and often carriers are required to go well out of their way to actually pick up the load. So the result is many millions of empty kilometres and lots of wasted time and inefficiency in the booking process.
A lot of the freight business is run through a broker or middleman who can take up to 15% for the privilege. OnTruck is one of a few new digital platforms that are trying to simplify this area and build an on-demand logistics platform.
I've worked in the industry for 25 years. I started life as a trucker, and I've seen firsthand how manual intervention and lack of process increases costs for our shippers and hurts earnings for our carriers. The OnTruck model connects carriers and shippers, breaks down organisational barriers, and allows an aggregation of volume.
The system is flexible. Whether you have a single pallet or a whole truckload of goods, it can team you up with the right carrier.
So the shipper books and requests a shipment through on truck. That sends a notification to the carrier. They see that on their smartphone. They review all the details of the shipment, the size, the weight, the vehicle specifications, any instructions the shipper's left for them, and they choose whether to accept or not.
The company has set out to target a particular distance of delivery, 150 miles.
If there's only 30 kilometres to go or 50 miles to go, empty, a shipper's more likely to tolerate that. But we think that's still waste, and that's a big opportunity for us to add value. And there's more of them than there are the long distance empty legs.
The system and the chosen range can help drive fuel efficiency and cost savings for the drivers and trucking companies.
By reducing the number of empty running miles for carriers, we effectively improve the total carrying capacity for the UK fleet. Because lower empty miles means the carriers are utilised more often and can carry more goods. Therefore, shippers can move more goods without the requirement for extra vehicles being on the road.
Road freight vehicles accounted for about 80% of the global net increase in diesel demand since 2000 and make up about half of global diesel demand today. So any technology that could make an impact on those figures will be most welcome.
Professor Anne Goodchild is based at the University of Washington in Seattle. She's a professor of civil and environmental engineering. She is the founding director of the Supply Chain Transportation and Logistics Center at the University of Washington and has 15 years of experience leading freight transportation research. Professor Goodchild, thank you so much for having us here at the University of Washington. Tell me a little bit about your job title and what you do here.
Yeah, I'm the director of the Supply Chain Transportation Logistics Center here at the UW. We are the center of research and teaching and learning around supply chain transportation logistics topics. I'm also a professor of civil and environmental engineering.
So, Professor Goodchild, tell me a little bit about intelligent freight, what it looks like today and what it will look like tomorrow.
So we are at the edge of a revolution. There's a wave of change that you can see hitting both passenger transport as well as freight. Services like Uber and Lyft. We really are seeing the opportunity to do new and innovative things in transport. I think a lot of that comes from our developments in sensors, in information systems, and in communications. So for me, intelligent freight takes those tools and delivers a better freight system, one that is more efficient, one that is faster, one that is more nimble. So for me, an intelligent freight system will be one that sort of wastes less, uses the least amount of energy, produces the least amount of emissions, but still is able to deliver the things that we need to serve our lives, particularly in cities, so that we can focus on other things.
So tell me, what key areas will reduce energy usage?
So I think there's a few. One is that most over-the-road vehicles, trucks, current marine vessels, airplanes, they are heavier than they need to be. So I think there's a lot of opportunity to reduce just the weight of the vehicles themselves. Also engine technology. We, to a large extent, we're using very old technology that was designed, at a different time when we didn't have the same pressures that we have now. So electrification of the fleet will absolutely provide energy savings. So I think weight and then engine technology are two key ones. The other thing you see happening is just sort of more operational, smaller scale improvements in terms of where vehicles go and when they go there and how they're packaged. One example, like laundry detergent, is mostly water. Right? So one of the reasons that we now have this high efficiency laundry detergents is that then you just don't have to ship so much water all around the world, which is cheaper for you and cheaper for the company producing it. So there's changes in packaging, in operations, in engine technology, and also just in engine vehicle design itself.
Europe's waters have seen many confrontations over the centuries, but today's policymakers are hoping that cooperation could be the key to sustainable freight transport. We set course for Brussels to take a look at a vision that could be making waves soon.
Most of Europe's great cities were founded because they're close to water. For hundreds of years, the wet stuff was key to the way we moved things around. But in recent years, the importance of water seems to have receded as trucks rather than boats took over as the #1 way to mobilize goods. Now, the European Commission is keen to turn the tide on transport.
Sea transport is a very important medium in the EU because 75% of our trade comes by sea. And so we need to develop a policy that is both efficient and works well for a majority of our trade to come by those means.
Europe has around 35,000 kilometres of coastline and hundreds of sea and river ports, which, if utilised more efficiently, could provide virtually unlimited transport capacity. Motorways of the Sea is a plan to encourage more usage of our waterways and to develop a more intermodal system to transport goods between ports and waterways and road and railways, making water goods transport more efficient and helping to take the pressure off our roads. Short sea shipping accounts for 41% of all moved goods in Europe, so there's a long way to go to fill water's full potential. One system being looked into allows a number of organisations to show information.
STM, sea traffic management, as an idea, comes out of aviation, where they have one air traffic control system for the whole of Europe. What STM does is the start of a project to bring that kind of principle to the maritime aspect of our work.
The system will allow ships to have a smoother and better planned journey, saving millions of tons of fuel as they don't have to speed up or slow down so much. The aim is to reduce voyage costs by 10%, a 30% reduction in waiting time, as well as providing 7% lower fuel consumption and 7% lower greenhouse gas emissions. Real-time monitoring with ship-to-ship information means that each ship knows the position of the other. It also helps to improve safety.
Well, it improves safety because ships know where each other is. They communicate with each other when they're at sea, and they can tell where each other is. So it stops collisions, and when you've got a busy seaway like the English Channel is, that's very important. And in bad weather, it's vital.
On the whole, Europe is underutilising its inland waterways, with them only accounting for 4% of all freight moved in the region. One key issue is the interoperability of goods containers themselves. One company is looking to do for canals what containers did for trucking.
The idea behind Water Truck Plus is to provide a long-term alternative for small inland navigation and to give the industry a means to make it economically viable to ship cargo on the smaller waterways throughout Europe.
The idea is to use small self-propelled or unpropelled standardised barges with large or small environmentally friendly push boats used for pushing the convoys. The concept ensures flexibility of operation by maintaining maximum regional coverage by connecting small inland waterways with the 10T network. The aim is to decrease the barge's noxious emissions using alternative fuel types such as LNG, CNG, hydrogen, hybrid.
The next generation engine types that we're using into our vessels have a higher efficiency than the generally very old engines that are still employed in inland navigation today. We see that most of the ships are 60, 70 years old, and the engines have been replaced maybe once. So the average age of an engine is about 20 years. And we see that there's been a lot of progress in the development of these engines in the past 20 years. So to use new types of engines will definitely help.
So history may be turning full circle as Europe's waterways once again become the arteries for greater trade.
How can we wean maritime freight off diesel? When we talk about marine freight and diesel, they seem to go hand in hand. How can we change that?
I think, changing to alternative fuels means changing the vessels and their engine technology. That's a huge kind of undertaking. It's a big cost. And so I think the most practical approach is an incremental one. But for smaller scales, for kind of feeder vessels that are doing shorter distances and maybe closer to power, then that might be an area where we could look to trying to introduce some real bigger changes, bigger innovations.
So how do we speed up change when it comes to maritime vehicles? How do we get to a point of more automation, possibly electric ships, things like that? How do we get there?
Within the United States, we've taken several approaches trying to manage marine terminals, and then also within the boundaries of our of the country. So actually, I think marine terminals are an area we've had a lot of success with electrification and the use of alternative fuels. Cold ironing, marine vessels plugging in rather than running their engines while they're in port.
Right.
So we've had some success there, and then also slowing the vessels as they approach the coast so that we reduce the energy consumption. That's something we've been able to implement domestically, and we see benefit from that.
So you just mentioned there about slowing the vehicles, and I believe that just going slower can reduce energy emissions. So is that the answer? If we just go slower?
Typically, depending on where we currently operate, going slower is more energy efficient, and that's certainly one approach. I think, how do we make a more sustainable freight system? That will require a lot of strategies, and we're going to need a lot of collaboration, participation from many different groups to try to get there.
Professor Goodchild, thank you so much for that. Please stay with me, I've got a bit more to ask you about. But first, think you know everything there is to know about moving goods from one place to the other? Well, think again. Here's one common misconception.
You thought you knew? Think again. Myth. The cost of sea shipping an item like a banana depends on the distance travelled. Fact. The actual cost is dependent on many factors, including origin, destination, volume, time of year, plus many other variables. For shipping companies to make money, they have to charge different amounts depending not just on the fuel and distance, but also on the destination and whether they can return with a different cargo, either from the destination port or a nearby one.
Air cargo is responsible for around 7% of trade-related freight emissions, but the environmental and energy cost of moving goods by air is coming under ever greater scrutiny. In Spain, we visited a company that's proposing a radical way of making air cargo more energy efficient.
There has been a lot of talk about deliveries by drone, but so far most systems deliver lightweight packages and over short distances. There are larger unmanned aerial vehicles, or UAVs, out there, but they're mostly for military use. One company in Spain wants to change all that by marketing a vehicle designed to help save lives.
The Flyox is a drone. It's a UAV. It's a remotely piloted plane. So at the end, it's a plane, and it's a tool to perform several types of operations. The only difference is the pilot is on the ground, is not sitting on the plane.
The plane is designed to be highly adaptable. The firefighting model can land on water to fill up its tanks, but it can also land on a conventional runway.
We have to deal with any type of landing surfaces. That's why it's amphibious. We can land on skis, on ice and snow. We can land on unprepared surfaces, and the plane is able to cope with that type of operation.
Another key area is transporting goods. Its designers say it could be highly useful in difficult environments.
We've signed agreements with Red Cross, World Food Programme to get food and medicine and aid to emergency situations as quickly as possible. In Africa and Asia, where weather constraints restrict delivery of goods and medicine, the Flyox can do this very efficiently and speedily.
And unlike a conventional drone, this UAV can go some serious distance and carry some serious weight.
We can fly more than 30 hours or stay 7,000 kilometers apart if you want to take that, or in the other case, as a standard 600 miles, you can go with nearly 2 tons of payload.
Of course, no pilot means no systems are needed, such as pressurized oxygen or even toilets. And that means the aircraft can be a lot more fuel efficient. They claim it's 40% more economical and 15 times faster than land transport, and from 6 to 20 times more economical than other similar aircraft.
We are able to fly in a location in Angola under 1 hour, when a regular truck today, on the same circumstance, for the same operation, takes 7 days. Compared to aviation, we are much more efficient than the aviation type of engines. So it will reduce the global amount of fuel used in this type of operations.
And while the control systems may be state-of-the-art, the engineering side of the aircraft is basic, for a good reason.
Simplicity in the design asks for being able to maintain this plane, all of its subsystems, including the engine, anywhere in the world. So the best knowledge around is automotive engines. The engines are very well designed, of course. They are the most efficient engines nowadays possible, even better than the ones we are used in aviation.
As the aircraft uses normal petrol, you don't have to find an airfield or use expensive aviation fuel. You can just fuel it up at your local petrol station. And it's not just economical to run, it's also cheap to purchase, which is causing a few waves in the industry.
We're selling it at a very low cost because we want to keep the cost of operations very low. Our average operational cost per hour is between $200 and $500 an hour. We're actually competing with a 4x4 Land Cruiser.
Heavy-duty drones still have a lot of turbulence to overcome, but Flyox thinks it's sky's the limit for this kind of technology in the future.
So what's happening now with drones and what will happen in the future?
I think drones are a really, we've brought the technology to a point where it opens up some really new possibilities that are exciting. Drones are so lightweight and so energy efficient that they really can compete in terms of sort of the cost of delivering with other modes. They also have the advantage of not being encumbered by congestion and traveling sort of shorter distances because they can do straight line distances. But there's also some real implementation challenges and airspace management problems. So I see them being implemented first in areas where overland travel is either really dangerous or impossible or really expensive, very remote areas, areas with very poor existing land infrastructure. And I think we have a lot of work to do in figuring out how to manage and ensure privacy and safety with that technology.
How can we be more sustainable in the goods and services that we consume?
I think we need to do a number of things, and certainly one of those is think about our role as consumers and what we buy and where it comes from. I also know that there's a lot of research. Some of that is happening here at the UW, but also sort of government agencies and the industry itself has really become aware of this challenge, and we have some exciting new technologies, both on the information side and also on the physical infrastructure side, that will allow us to build a better goods delivery system that improves quality of life and brings joy to city dwellers every day.
Thank you so much, Professor Goodchild. It's been so interesting learning all about it.
It's been a pleasure.
As we have seen, our appetite for goods and services from all around the world is fueling great growth in the freight transportation sector. But with this growth comes a rising energy cost. We either have to consume less or get smarter about how our goods reach us.
Next time, how can we power mobility more effectively and efficiently? We'll take a look in the tank to see what's fueling our future. And if you have any questions for our next expert in fuel, then you can get in touch with us in all the usual ways on Twitter at CNBC Energy using the hashtags AskSE and Sustainable Energy. But until our next delivery, keep thinking green. Goodbye.
Bye.